Hello, it's Poolside with Miss Ricketts, and today we're talking about floating or sinking. Less dance and more dance. So let's get started, my scientist. Hey everybody! Hello! Miss Ricketts here. Guess where I am? The Bahamas. No. Hawaii. No, I wish. But I am in the swimming pool in my swimming shirt, enjoying everything. And you know what I'm doing? You see my toes? That's right. I'm floating. So I bet you guessed already what today's lesson is going to be about. It's going to be about sinking and floating. Sinking and floating. And for my upper grades, my fifth graders, we're going to introduce the phrase relative density. More dense, less dense. So join me for our time in fun in the sun and in the pool. Remember, the world is your laboratory. Here we are in our luxurious pool. And I have a tank of water here. And let's discuss our terms, our vocabulary. I have household object. I have a little plastic container. And let's see what it does when I put it in water. Look, it didn't go down. It's on top of the water. That's considered floating. We would say the plastic container is floating on the water. Above on the water. Here in my hands, I have a can opener. Everyday household items that you would have. Let's see what happens when I put it in. Uh-oh, it went straight to the bottom quickly. So we would say in the complete sentence, the can opener sank or is sinking at the bottom of the water or below the water. Above, below. Above, below. Float, sink. Float, sink. Let's use some more household objects and let's look at whether they sink or float. But before we do, we're going to make a data chart and make a prediction. Be right back. Now let's take a moment to look at our picture vocabulary. Matter. Anything that has mass and takes up space. Matter. Mass. The amount of matter in something measured in grams. Float. To stay on the surface of a liquid without expending energy. Float. Sink. To drop below the surface level in a liquid. Sink. Density. How much mass a substance has in a given space. Density. More dense. To drop below the surface level in a liquid. Sink. More mass per volume. Less dense. To stay on the surface of a liquid without expending energy. Float. Less mass per volume. Here we have our data chart for sinking and floating. If you look in the first column, we have the object, and the second column, we have the prediction and observation with the picture flashcards in each one. You just circle one, float or sink. So let's look at our objects. We have scissors, toy race car, ping pong ball, wooden golf tee, golf ball, metal spoon, plastic spoon, mirror, plastic knife, pencil, and foam globe. I've left some open spaces so you can create your own objects and put whatever you want in. Okay, so we're back at our luxurious pool and we have our objects and we already made our predictions. So let's go ahead and see if our predictions were right. Here we have scissors. Oh, the scissors sank. Here we have our race car. Ooh, the race car sank in the water. Here we have our ping pong ball. It got away from me. Here you have a ping pong ball. Oh, it's on top of the water. Can you see it? Right here, it's on top of the water. Ooh, isn't that interesting? Here I have a wooden golf tee. Let's see what's gonna happen when I put it in. It too is on top of the water. It's floating on top of the water. Let's see what else I have. Household item. Oh, my dad likes to play golf, so here's a golf ball. It looks just like the ping pong ball. Let's see what happens. Ooh, it sank to the bottom. What else do I have? Ooh, I have a lot of stuff in my bag. Here's a metal spoon. Now we've seen stuff happen with metal, so let's see if we want to revise or change our prediction. Wow, the metal spoon sank. Here's the plastic measuring spoon. Oh, it's floating on the top. Let's see what else we have that you can see. My mirror, my compact mirror, it has plastic and metal. It sank to the bottom. A plastic knife. It sank. No, did it sink? Oh, the knife, the plastic knife sank. Isn't that interesting? Not all plastics float. Here's a wooden little mini pencil. And it floated. I gotta have a ball here, a little globe. Let's see what happens when I put the globe in water. Cool. So after we actually did our investigation, how were your predictions? Let's make some observations. I thought all plastic would float, but it didn't because the plastic knife didn't. So I guess some plastics are different. A lot of my metal, it sank. A lot of my wood, they floated. So I guess a general rule is that wood floats and metal sinks. But I thought all my balls would float, but this one floated, but my golf ball, it sank to the bottom. It's interesting. Let's do some more and see what kind of results we got. Big versus small. Does size matter? I also noted that even though this ball was bigger than this ball floated and this ball sank. I'm kind of confused. I just thought that big things would sink and little things would float, but that wasn't the case. Let's look at this in terms of fruit. We'll be back with some fruit in a minute. Okay, we're back. And now I have some fruit. They're both round, right? Are they the same or are they different? They're different, but they have some similarities. They're both round. They're both green, but they're different. How are they different? This one is definitely bigger and heavier than this one is. This, of course, is a watermelon, and this little thing is a lime. Watermelon, ow, 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 and a lime. I just wonder if I put both of these fruit in the water, which one would sink? Which one will float? Do you know? Let's take a pause, some thinking time, and make our prediction. Good. How many of you said the big heavy watermelon would sink? Okay, I see some hands. How many of you think the little lime will float? I see a lot more hands. Well, let's find out. Here we go. Drum roll, please. Oh, wait a minute. It's going down and up and down and up and down and up. Look at the watermelon. It's floating. It's floating at the top of the water. There it is. It's not sinking. Here we go. Ready? Can you see the line? Drum roll, please. Uh-oh. Uh-oh. Wait. Uh-oh. Oh, I caught it. It kept on going down. Let's try it one more time. Hey, oh. It's at the bottom of the pool. I'm not going to mess my hair up to get it. But it just goes to show you, size is not always the thing that makes something sink or float. There's more to it than just the size. Let's take a closer look. Sinking soda, taking size out of the equation. Regular soda versus diet soda. So here we go. We're back. Now we just did an investigation with fruit. We had a big, juicy watermelon, and what did it do? It floated on top of the water, and it was so heavy. I didn't think it would float. And then I had a little bitty lime, and it sank. So it can't have everything to do with size. So let's take size out of the equation, and let's do something that's size equal across the board. Ready? Let's do some soda. Now, Miss Ricketts is not supposed to buy soda and drink soda, but you know, it's for science, for the children, so I had to buy it. So what do you think? I have grape soda, same, let's say it's 12 ounces. Let's carefully put it in the water. Carefully put it in. Oh my goodness. It sank. Can you see it? Now I have some Pepsi. It too is the same size, same shape, same can, and it's 12 fluid ounces. So we're taking size out of the equation. Everything is the same when it comes to size. Let me very easily put it in. Wait a minute. The Diet Pepsi is floating, but the grape soda is sinking, or it sank. But it's the same size, same shape, same container. Let's see what else we have. Orange soda. Let's see how much. 12 ounces, 12 fluid ounces. I wonder what this is gonna do. Very carefully, let me put it in. Oh my God, just like the orange, just like the grape soda, woo, sank to the bottom. Very interesting. I have some diet orange soda. Same type of can. Let me see. Does it say 12? Yes, 12 fluid ounces. Now, if this diet soda floats and these two non-diet sodas sink, what do you think this is going to do? And can we come up with some sort of rule or pattern or trend? Can we see it? Okay, let's find out. Drum roll, please. You have your prediction. You sure? Okay. Very carefully. I'm gonna put it in. Oh, you see it over here? It's floating to the top. And it went right next to the Diet Pepsi. So both cans of Diet Soda, they're floating. Both cans of regular soda sank. Let's see if this will work. Here it is, regular Pepsi. What do you think is gonna happen? It's not diet, regular. Let's see what happens. Carefully put it in. Carefully, carefully. Oh, it's floating too. Hold on. Uh-oh, this has a leak in it. I see it right now. Let me get one that doesn't have a leak. Well, I'll be right back. Here we go. Here we go, here we go. Let's see what happens. Push this to the side, slowly. It's 12 fluid ounces. Oh, it sinks too. Diet sodas float. Regular sodas sink. Same size, same shape, same amount. How can we explain this? I'm going to give you some ponder time to come up with your theory on why these float and these sink. Relative density. And we're back. And let's introduce a new term called relative density. Even though that these are the same size and same shape and have the same amount of fluid in them, they're different. The diet soda has no or very little sugar in it. The regular soda has a whole bunch of sugar in it. So there is more weight or more mass in the same size container. Look at these two containers. These look like our soda containers. Same size, same shape, take up the same amount of space. But in this container, I have a lot more matter, a lot more stuff, compacted, stuffed inside of it. So it has more mass. The same container I bought at the same store only has a couple of balls in it, and they have room to move around. They're not stuffed in. This one has more stuff, more density, more dense. This one has less stuff, less matter, less dense. So, which one do you think will float or sink? Good, you're right. This one would be on top, floating, and this one would be on the bottom, sinking. But let's use our new terms. Less dense, less stuff, less matter, more dense. Float, less dense. Sink, more dense. Here, just let me show you how it looks with our cans. Our floating diet soda, I'm going to put right here with just the two balls. I'm going to take our regular soda and put it on this container with more balls. Again, less balls, less dense, float. More balls, more stuff inside of it, sinks. Relative density. Relative density. This will float in relationship to the water. This will sink in relationship to the water. Woo! We've done a lot today. We've done a lot today. But let's do one more thing. Now let's use the next video to practice and apply what we've learned. Remember, You have to verbalize to internalize. So we're going to sharpen our speaking skills. Let's talk about some more fruit. I have orange here. If I put this orange in the water, what do you think is going to happen? Let me take the soda out. That's right. Let's see. It floats to the top. The orange with the peel floats to the top. Now I have this orange, and I took all the rind and all the skin off. Now, if this orange with all this on it, more matter, more mass, more weight, if this floats, what do you think this is going to do? Let's find out. Wait a minute. It sank. The orange without the rind sank. Why? Because in the rind, there's a secret. They're little floaty devices. The rind are like little floaty devices that you put on your arm to stay up. So even though there's more mass, there's more air in here to help keep it up. Just like when a little baby goes swimming and wears the little floaty things on his arm, you fill them with air so they don't sink. They stay up on the water. Guiding questions. Please answer the following questions based on the previous video and this picture. Why did the orange without the peel sink? You may use the sentence stem, the orange without the peel sank because. I'll give you some think time. The orange without the peel sank because it had a greater density compared to the water. Next question. Why did the orange with the peel float? You may use the stem. The orange with the peel floats because. Again, you may use the sentence stem. The orange with the peel floats because. I'll give you some think time. The orange with the peel floats because there are pockets of air in the skin or peel of the orange. The air is less dense compared to the water. One of these things doesn't belong. One of these things is not like the other. One of these things just doesn't belong. One of these things is not like the other. Can you tell me by the time I finish the song? I'll give you some think time. In light of what we learned today about sinking and floating and relative density, can you find out which one of these things just doesn't belong? 10 seconds. Let's find out. If you said the Diet Sunkiss or the Diet Soda, you're right. All the other sodas are full of sugar and they sink in water. They have greater density than the water. The Diet Soda has less density, so it will float on top of the water. Wow, you're fantastic! Checking for understanding by playing quizzes. Game of quizzes. Scientist. Metal ring. It's metal. It's going to sink. Yay! Brass brad, it's metal too. It's going to sink in the water. Cardboard, cardboard's like paper and wood. And those toothpicks and pencils, they were floating in the water. So I say float. Foam sheet. A foam sheet is kind of like the orange skin. It has a lot of air in it, air pockets. I'll say float. Yoo-hoo! A paper clip. Paper clip's metal. Definitely sink. A penny. Pennies metal. Metal sinks. I know, like in Second Treasure, they sink. It doesn't float. I wish it did. Oh, a plastic straw. Plastic straw, it usually floats. Yeah, but a lot of plastic floats. Steel washers, that looks pretty heavy for its size. It'll probably sink in water. Metal, steel. Wooden bead, wood, and we know that most woods float, so I'm going to say float based on our past experience and investigation that we did. Golf ball. Golf ball was pretty heavy. There's a lot of stuff packed in a golf ball, so definitely sink. Plastic chip. Not all plastics float like I thought they would. It's kind of like our knife, so I'll probably say sink. Ooh, ping pong ball. It's nice and light for its size, not like the golf ball. It floated on our water. Rocks, they sink to the bottom. They go down. Craft sticks, they're usually made of wood, and wood usually floats. I'd say float. Ooh, our visual literacy. We have all these things. Let's see. A golf ball, cardboard, metal ring, brass brad. Well, I know the metal ring and brass brad will probably sink because we've worked with that. And the golf ball, it's heavy for its size, it will sink. And the cardboard is like wood, it will float. So we have sink, float, sink, sink. So it's definitely the cardboard that doesn't fit in. Yay! The end! Woohoo! Would you like to play? Okay. Let's see what we can do. If you want to enjoy a game of quizzes, go to joinmyquizzes.com. For my primary grades, the code is 067 65680. That's 067 65680. For my upper grades, go to Join Quizzes, and the code you enter is 18398320. That's 18398320. Have a fun time. Whew. This has been a fun lesson. I've enjoyed it. Have you? Oh, it may not be Hawaii. It may not be Jamaica. It may not be the Bahamas. Oh, but Miss Ricketts loves the water. And science is everywhere. Remember, until next time, it's Miss Ricketts saying bye, and the world is your laboratory. Bye-bye.